So, before, and again, we get out of here in 30 minutes, so we only have 30 minutes. We're going to do as much as we can. Before we start on these examples, let's just make sure we remember. We learned a couple points of concurrency last class period. They were made by perpendicular bisectors and angle bisectors, right? What was the name of the point of concurrency that was made by perpendicular bisectors? Somebody started to say it. Circumcenter. Circumcenter. Does anybody remember what was true about the distance from the circumcenter, or what the circumcenter theorem said? Very good. The distance from the circumcenter to each angle or each vertex is the same distance. They're congruent. Okay, then we had a second point of concurrency that was made by angle bisectors. What was the name of that point of concurrency? In-center. And what was true about the in-center? It was also equidistant somewhere, but okay, it is always inside. That's correct. Good. But what was its theorem? Equidistant from the sides. Okay, equidistant from the sides. And here's how I remember it, Naomi, is if I'm going through the angles, so if I'm making angle bisectors, I'm going through the angles, right? So the point of concurrency is not going to be equidistant to what I just went through. It's going to be equidistant to the other location. So that means it's going to be equidistant to the sides. Does that make sense? Okay. So those were the two big theorems in 5.2 where we left off. So let's pick back up in the notes. Did we do this example? Or we did this one, right? Okay, let's just get our minds wrapped around. I'm going to go back over this example one more time and make sure everybody's with me. So it starts out telling you that you have angle bisectors. First thing we did in this picture is we marked the picture with what was being bisected, and we did it really fast right at the end of the period. So I want to make sure you really understand. So MP and LP are angle bisectors of this triangle. So what is MP bisecting? Angle LMN. If it is an angle bisector of the triangle, it's bisecting the angle that it goes through. So you should have marked in your picture that those two angles were congruent. Okay? And then it said LP was an angle bisector. So what's being bisected? MLN. So that's this angle. Angle bisector. So you're looking at the angle of the triangle that's being split. Okay? So if these two angle bisectors meet here at point P, what did we call point P again? Careful, that's perpendicular bisectors. In-center. So angle bisectors goes with in-center. Okay, and so the in-center theorem that we just reviewed is that the in-center is equidistant to the sides, okay? So in this example, we said then if I go from P over to the side and always draw it perpendicular, from P over to the side, perpendicular, from P over to the side, perpendicular, all of those distances should have been the same. So then read the question. Find the distance from P to side MN. So from P over to side MN. What should that have been the same as? The QP. And what was QP according to the picture? 5. And so because QP was 5, so was P over to that side. So our answer we had on our paper was 5. Does everybody really understand that today? Okay, now let's look at the next one. So once again, it's the same picture, same directions, but this time they want us to find the measure of angle PMN. So I'm going to go back and remark what you guys told me a minute ago. This angle is being split into two congruent parts by this angle bisector. This angle is being split into two congruent parts by this angle bisector. And so now we're looking for PMN. PMN. This angle right here. So ideas, things you notice that we can mark. Chris? Which angle? You are right about, I don't know if it's the one you're talking about, but the words you just said, 50 and congruent, there are two angles that are congruent, so another one would be 50. Which angle would it be, though? Say it again. QMN. No, that angle would not be 50. Notice that this is being split into two congruent parts, but that just means they're equal to each other. This is being split into two congruent parts, so they're equal to each other, but they're not all equal to each other together. Okay, so what other angle is going to be 50? Jacob? QLP. So if this PL is an angle bisector, then it's splitting that angle into two congruent parts. So if this is 50, then this angle next to it is also 50. What does that make the big angle L? 100 degrees. Does everybody see how that's 100? Okay, so this big angle right here is 100 degrees in the triangle. And we also know that angle N is 20 degrees in the triangle. And what do we know about all three angles in the big triangle? They have to add to be 180. So could we find the measure of the big angle M? Okay, so if this is 100 and this is 20, what would this big angle have to be? 60, because we have 100 plus 20 is 120, and then 180 minus 120 is 60. Is that our answer for what they're asking, though? No, we have to split it in two because we know that MP is an angle bisector. So if this big angle is 60, then this line right here is splitting that into two congruent parts. So what is our measure of angle PMN? 30 degrees. Does that make sense? Okay. All right, so I'm going to go back to the example that we skipped, which was the graphing question. So if you can go back to the one that was on a graph, it should be blank in your notes. We didn't go over it, and I think it was this one. Maybe. Not this one, but the next one. Yes, this one right here. And did I go ahead and give you the picture of the graph on your paper? Okay, so on your homework, it may not give you the graph. It may just give you the 3 vertice points, and you're going to need graph paper, and you'll graph the triangle. Be really careful because some of you still get confused when it's 10, 0. Sometimes you go to 0, 10 and make a mistake, or 0, 6. Sometimes you go 6, 0 and make a mistake. So be real careful on your graph. Graph your picture. Okay, what's it asking us to find? Circumcenter. So you're going to have to think back. We've only learned 2 points of concurrency so far. What kind of lines make the circumcenter? Okay, so perpendicular bisectors. Okay, we've only learned 2 types of lines, perpendicular bisector or angle bisector. The perpendicular bisectors make the circumcenter. The angle bisectors make the incenter. Okay, got to get those 2 things together in your mind. So when you read the question, you're going to have to know circumcenter is made by perpendicular bisectors. And so what we're going to have to do is find those perpendicular bisectors and find out where they cross. That's our goal. We want to find the point for the circumcenter. So we need to draw in the perpendicular bisectors and find out where they cross. Will we have to draw in all 3 of them? No, because as soon as 2 of them cross, we know exactly where the third one's going to have to cross because they're all going to intersect at one point. So we really only have to draw in 2 perpendicular bisectors. And this problem is not too hard because they give us a vertical and a horizontal. So if I'm trying to draw a line that's perpendicular to a vertical line, what kind of line is perpendicular to a vertical? Horizontal. And if I have a horizontal line, what kind of line is perpendicular to it? Vertical. And so those are going to be easier to find perpendicular bisectors. Okay? Where does a bisector have to go through? The midpoint. So the first thing I would do if I were you is I would take the sides that are either vertical or horizontal and find their perpendicular bisectors. If this is going from 0 up to 6, where's the midpoint? 3. And then because this is vertical, one more time, what kind of line should be perpendicular to it? Horizontal. So we're just going to draw a horizontal line right through 3. So there is 1 perpendicular bisector. We only really need 2. We could draw in all 3, but we only have to have 2 because as soon as they intersect, that's the point that's our circumcenter. Okay, so go to the horizontal line. If it goes from 0 to 10, what's the midpoint? 5. So graph that point. And since it's horizontal, what kind of line is going to be perpendicular to it? Vertical. So now draw a vertical line right through it. And then look at your graph and tell me, where did your two lines intersect? Okay, at +5, +3, right? So the answer to the question is, what is the circumcenter? Your answer would be 5, 3. So you're drawing in the perpendicular bisectors. Questions? Okay. That is 5-2. Anything at all that we need to go over? All right, let's see if we can start 5-3 and get as far as we can here. All right, 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I need to take roll. So help me see here. We're missing Mallory. When we get back from break. So with the day we come back is Monday. We won't have class. We'll have class on Tuesday. So it's due Tuesday after break. You can turn it in. If you have it done, you're welcome to turn it in. Good. Awesome. Okay, help me out real quick, guys. I'm missing Mallory and Tori and one other person. Who am I missing? Mallory and Tori, and unless I can't count, I'm missing one more person. Michelle. Is Michelle here? No, Michelle. Okay. So here we go. 5-3. Focus 5-3. I know you're in groups, but try not to talk to your partners right now. Look at your 5-3 notes. So what we're going to do in 5-3 is learn 2 more types of lines, 2 more points of concurrency, but fortunately only one of them has a theorem. Okay, the other one doesn't. So you're going to learn 2 more kinds of lines, 2 more kinds of points of concurrency, and then 1 more theorem that goes with it. So first kind of line is a median. All right, and I need to make sure that you're getting clear in your head the difference in the markings. So if I have a triangle here, this is one kind of line we've already talked about. This is another kind of line that we've already talked about. And then this is a median. Okay, so this is a median. I'll go back to the median in a minute. First of all, tell me, what is this type of line? Perpendicular bisector. It's making a right angle and it's splitting the side of the triangle into 2 congruent parts. What is this? Angle bisector, splitting the angle into 2 congruent parts. So now we have a median. What is different on the median than on the perpendicular bisector? Okay, it's just a line segment. Okay, it's going from the vertex to the midpoint. Perpendicular bisector still goes through the midpoint, but it doesn't have to go through the vertex. What else? It's not a right angle, right? It's not perpendicular. So I need you to make sure you understand the difference in your markings to know what kind of lines you have. So a median of a triangle goes from the vertex, has to go from the vertex, to the midpoint of the opposite side. And then just like last class period, we're going to draw in all the medians and find out where they cross, and it's going to have a special name, that point of concurrency, okay? So First, on your paper, this time I did not give you the picture where we had the acute, the right, and the obtuse triangles. So I want you to go ahead and draw those in. On your paper, somewhere, the bottom, wherever you have room, draw in an acute triangle, draw a right triangle, and draw an obtuse triangle. And we're going to see what happens when we draw in all of the medians. So one more time, where's the median going to go from and to? From vertex to midpoint. Okay, median goes vertex to midpoint. So what you're going to do is just estimate. We're going to do this quickly. We're not going to use a ruler and actually find the exact midpoint of every side. But just pick a side on your triangle and estimate about where you think the midpoint is and mark the sides congruent. Hey, Michelle. We just finished up the 5-2 notes, and I handed out, did you get my remind message that said the assignment last time was the wrong assignment? Yeah. Okay, so here's the corrected slip for that, okay? And then this is the new notes that we're going over right now. We just got started because we finished the 5-2 ones, okay? You can sit wherever you want. Okay, doesn't matter as long as you can see the board. Okay. All right, everybody back up here with me. So we're going to go from the vertex to the midpoint. You pick where you think the midpoint is and mark the sides congruent. Draw from the vertex to the midpoint. And do that for every side of your triangle. You with me, Dylan? So find what you think is the midpoint and then mark your side congruent and go from the vertex to the midpoint. And then do the last side. About where you think the midpoint is, vertex to midpoint. And if you do it correctly, they should all intersect at one common point. Now, since we're just estimating, yours may not quite all cross at one point, and that's okay, but just kind of fudge it a little bit until it does look like it's all at one point. If you used a ruler and really measured the midpoints, then it would intersect in one common point. Okay? That common point is called the centroid. So that is our third point of concurrency. And I told you, I'm going to give you an acronym at the end of this lesson. It may not be until we get back from Thanksgiving break, depending on how far we get. But I'm going to give you an acronym that I hope will help you keep straight which line makes which point of concurrency, okay? But this is called the centroid. All right, so where is the centroid going to be if it's acute? Inside, outside, or on the triangle? Inside. All right, let's go to the right triangle and do the same thing. So go to the side, pick where you think the midpoint is, mark the sides congruent. Use the other color. And then go from the vertex to the midpoint to draw in your median. And I'm going to keep saying that so it starts to stick in your mind. Vertex to about the midpoint of the opposite side, median. And then do the last one, where you think the midpoint is, mark the sides congruent there, vertex to midpoint. And if you did it correctly, they should all intersect at one common point. And again, what's the name of that point? Centroid. The more you say it, the more you write it, the more you're going to memorize it. Where is the centroid if it's a right triangle? Inside. Okay, last one's obtuse. Again, you're just estimating about where you think it is, midpoint. Mark the sides, vertex to midpoint, median. Midpoint of the next side, about where you think it is, vertex to midpoint, median. And then the last side. Mark the tick marks. Make sure you're using a different number of markings. And vertex to midpoint, median. And again, it intersects at one common point called the centroid. And where is the centroid if it's obtuse? Inside. And Bailey reminded us of this from last class period, but one of the two we learned last class period was also always inside. Was it the incenter or was it the circumcenter? The incenter. The incenter was always inside. The centroid is also always inside. Okay? It is our most special point of concurrency. There are several things about it that are true. The first thing that's true about it is that it is called the center of gravity. And what we mean by that is if I had a triangle and I wanted to take that triangle and stick it on the tip of my pencil and get the triangle to balance, where I would need to place the tip of my pencil is at the centroid. It's the balancing point. It's the center of gravity. So it is where the triangular region will balance. It is directly in the center of your triangle. Okay? All right, and we reviewed at the beginning of class, perpendicular bisector creates the circumcenter and it's equidistant to the vertices. Angle bisector creates the incenter and it's equidistant to the sides. The medians create the centroid, and it is not going to be equidistant to anywhere, but it does have a special theorem about it. The centroid theorem says that the centroid will split your median. So look at the median. Here's our centroid. It's going to split that centroid into two pieces. One piece is going to be 2/3 of the whole thing. The other piece is going to be 1/3 of the whole thing. Are you guys with me? So it's going to split it into two pieces. Every median. So here's a median. I'll draw it with a different color. The centroid splits that blue line into two pieces. Do you see the two pieces? We've got CP and XP, two pieces. One of those pieces is going to be 1/3 of the whole thing. The other piece is going to be 2/3 of the whole thing. Do you see it there? Okay, you have to know which one is the 1/3 and which one is the 2/3. So they say it kind of weird here. I'm going to write it different. If I were you, I would write this down. But it is the centroid to the vertex is equal to 2/3 of the median. So if you go from the centroid to the vertex, that's the 2/3 part. Put your pencil at the centroid, go to the vertex, that's the 2/3 part. Or you could say, go from the centroid to the side. That is equal to 1/3 of the median. And I'll give you an example with numbers that'll help make this make more sense. Okay, so your centroid splits each median into two pieces. One of them is 1/3, one of them is 2/3. Centroid to vertex is the 2/3. Centroid to the side of the triangle is the 1/3. Let me give you an example. So median, oops, that's not very good. Median. Splitting it where they intersect is our centroid. Everybody with me up here on the board? Okay, so if this whole piece is 15, we're going to take 15 and we're going to divide it into thirds. What is a third of 15? 5. So if this is A, this is B, and this is C, which piece is going to be 5? BC. From the centroid to the side is going to be 5. What is B up to A going to be then? 10. 2 of the thirds. So if 1 of the thirds is 5, then 2 of the thirds is 10. Does that make sense as far as just mental math, not having to actually write out numbers and fractions? Okay, so you can take your total distance and divide it into thirds by dividing it by 3. And then 1 of those thirds goes from the centroid to the side, and 2 of the thirds goes from the centroid to the vertex. And that's the centroid theorem. Okay, so let's try some problems. Here's the first one. And then if you're having trouble mental math with the division, I can show you an equation you can write down. So if we look at this picture, they tell us in the picture that RL is how much? 21. Okay, sorry, 1 second. This is Ashley. It's okay. Uh-huh. Can I send him like right when they dismiss them to go to their CAP teachers? We're finishing up our lesson and we'll be done in just like 5 minutes. Okay, I'll send him straight to you then. Thank you. Bye-bye. Yes, you need to go to the counselor's office when we dismiss in 5 minutes. Okay? Okay, so first of all, I'm going to say this one more time. Haley, you should not have a Chromebook app. Thank you, ma'am. When you look at your picture, the hardest part, I feel like, when you get to the test for Chapter 5 is looking at the picture and even knowing what in the world do I have in my picture. So that's why I asked you, what is this? What is this? What is this? When you look at the picture, how do I know that I have medians here? Okay, there's no right angle boxes, so there's not perpendicular bisectors. And the lines that are drawn are going from the vertex to where? The midpoint of the opposite side. And I know they're midpoints because of those congruent marks. Does everybody see that? Okay, so you see that you have medians, and that means that point S then becomes the centroid, and that means it's splitting that line into 1/3 and 2/3. Okay, so they tell you RL is 21, and they ask you to find LS. So look at LS. Is that the 1/3 or the 2/3 part? 2/3. So take 21 and divide it into thirds. What is 1/3 of 21? 7. Okay, hold on real quick. Jacob, everybody with me that 21 divided by 3 is 7. Okay, so that means 1 of the thirds is 7, but we said LS is 2 of the thirds. So what's 2 times 7? 14. So LS would be 14. If that doesn't make sense, then here's what you could write down as an equation. So write this down if you're not sure you're going to be able to do the fraction part. SQ is for the next problem. So they're giving you information and they give you 2 questions about the same picture. Okay? So SQ is not needed for this part. All right, so here's the equation you could write down if you're having trouble. We know that LS is 2/3 of the whole thing RL. Now you'll have to know that it's the 2/3 part of the whole thing. And then you just plug in the number they give you for RL. 2/3 times 21. And you can grab your calculator. If you're not sure what 2/3 of 21 is, type it in, and it'll tell you LS is 14. So if you need an equation, write an equation. If you don't need the equation, just do the math mentally in your head, and you don't have to show me the work. Okay? So let's do one more, and then we're going to stop. Same picture, same problem, but this time they give you SQ and ask you to find NQ. So they tell you SQ is 4, and the question is, what is NQ? Is NQ the 1/3, the 2/3, or the whole? Careful, look at your picture. NQ, is it the 1/3, the 2/3, or the whole? The whole. SQ, is it the 1/3 or the 2/3? 1/3. So if one of your thirds is 4, what is 2 of your thirds? 8. So that means we know NS is 8. And so what is NQ then? 12. 8 plus 4, which is 12. Okay, I'm going to say that again. If one of the thirds is 4, what's 2 of the thirds? 2 times 4 is 8. So we know that the other piece must be 8, which means the whole thing would be 8 plus 4, which is 12. Again, if you need an equation, here's what you could write down. NQ, look at the picture, is the 1/3 part, and it's 1/3 of the whole thing. NQ. Plug in what they give you. Or excuse me, that's not right. SQ is the 1/3 part, so sorry, and it is equal to 1/3 of the whole thing, NQ. And then plug in what they give you. SQ is 4, and then work backwards to solve for NQ. What would you do to solve for NQ? Multiply by 3 or divide by 1/3. It's multiplication here, so we wouldn't subtract. Be careful. Divide by 1/3 or multiply by the reciprocal 3. So if I multiply both sides by 3, NQ is equal to 12, which is what we got just doing it mentally. If one of the thirds is 4, 2 of the thirds is 8, 8 plus 4 is 12. Does that make sense? Okay, here's the